Morning, I'm Cayetano Carbajo, and it is my pleasure to be here today to share Telefónica view about the transport strategy and the automation of the transport. As I said, I'm Cayetano Carbajo. I'm leading core and transport in Telefónica Technical Corporate Unit. I've been 25 years in Telefónica in many different functions. I was CTO in Telefónica Germany. I have been CTO in Telefónica Mexico, but also I have had a lot of responsibilities in the global technical unit, in the corporate technical unit of Telefónica, what we call global CTIO. So as I said, I will be sharing with you our transport and strategy and the automation of the transport that we are implementing. So the transport strategy we have, the transport programs of transformation we have are defining three phases or steps. The first one is the technological evolution. We had a project called Fusion and the optical transformation. What we did with that is we limited the number of layers in the IP network. We concentrate in one node several of the functions. And this has given us the right efficiency for the increase of traffic that we have been experiencing in the last year. And also we have transformed our optical networks in order to complement this IP network and be efficient from traffic point of view. What we are doing now in this project is increasing the number of functionality we have in the transport network for dealing with the challenges we have ahead, for instance, the 5G implementation, but not only that, we are deploying XGPON technology in the fixed access that is increasing the traffic substantially. And we have several other challenges ahead, like Edge. The second step, I would say, is the automation of the transport network, the implementation of the SDN. We call this project in Telefónica iFusion, and I will be explaining this in detail later on. The third step is what we call Open Fusion. That is the disaggregation of the transport nodes, both in IP and optical. And we are doing that using the capabilities of the SDN controller. In the IP network, we have already working in the production network IP component that we have the hardware from one vendor and the software from another vendor. In the optical layer, what we have, the disaggregation we have is the usage of transponder from different vendors than the line of the optical transport network. So we want to increase the usage of this disaggregation in the future, and this is one of our line of evolution as well. We have a lot of technologies that will be drivers of the transport evolution in the future. What are we looking at exactly? Well, first of all, the needs of traffic steering and segregation of traffic are increasing, and we have several technologies that are coming that maybe will be used in future for this, and we are exploring. I think routing is a clear candidate, but you have some others you can see in the slide. Another important technological fact to be taken into account is the RAN evolution. The implementation of the 5G will increase the level of requirement to the transport network from different functionality, like for instance, the sync requirement, but there will be many other, like the distribution of the core network element that will impact our transport network. Also, there will be many requirements in terms of latency. So time-sensitive networking or flexible Ethernet or even deterministic IP are technology that we see as candidate in the future to be used. This is being explored in the now, and we will see what is the usage that we do of this technology in future. There are also some encapsulation mechanism that will allow us to be more efficient in the transport. And for sure, the level of security has to be increased. I mean, security is always a challenge, and it is increasingly important provide security in the transport network. We have to deal with this. As I said, radio evolution, mobile access evolution is a key factor for us in the transport network, and this is increasing the requirement of the transport network. We see the evolution of the access, mobile access, and also the evolution of the transport that is used as backhaul of it as waves, as you can see, as steps. So in 2020 or 2021, we will have in the radio mainly non-standalone, and then what we have is to use the transport for increasing the capacity. The capacities continue growing with 4G, but also with 5G, even in the non-standalone mode. So we have to increase the capacity. Also, we have to extend the fiber connectivity. We have to increase the number of sites that we are connecting with fiber, not only because of capacity reason, but later because of latency issue. We have plans in all the operation for bringing fiber to majority of our sites. There are operations in which we have fixed operation that it is easy, the pure mobile operation, like for instance, the operation we have in Germany, or till now in UK, it is more difficult to bring fiber to the site. But in those countries, we have plans for during the years having fiber in a big percentage of the sites. The second wave will be when the enhanced mobile broadband will be extended, and 5G will be the per default technology in the mobile access. The majority of the traffic will be 5G already, I think, in 2022, 2023. So we have to increase capacity. Maybe we will have already some distributed capabilities. We will be distributing the core of the mobile network, and we will be using new bands that will provide us with a lot of capacity in the access. So we have to provide even more capacity in the transport. These new bands and the usage of TDD will mean that we will need the synchronization mechanism that I mentioned before. And finally, the ultra reliable and low latency network that 5G standalone mode will bring will need likely and major upgrade in the transport network for reducing even further the latency, maybe with the usage of some of the technology that we have seen before. We don't see that before 2023. So if we go in a bit more detail in the technology, we think that we have to go for providing the right access to 5G, sorry, the right backhaul to 5G to a completely programmable transport network, and this is SDN. We will see this later. Especially in the 2022-2023, we think that disaggregation will play a key role because we will have the need of doing a complete renovation of hardware, we think, and this will be relevant for that. We will increase the capacity with higher speed interfaces and with capabilities for saving fibers in the backhaul. We have to include synchronization, as we said. So phase synchronization is a requirement for 5G TDD, and we have to do so. And we have to implement new technology for reducing even further the latency and doing this latency more deterministic. So a lot of technology to be implementing just because of 5G. It is important to highlight that there are many technology, but we have not an end-to-end standardized way of obtaining all the capabilities we need for the 5G network. So we have to do so internally in the organization in Telefónica. So these were the general transport strategy we are following. I would like to talk now about the SDN, about what in Telefónica we call iFusion project. iFusion is the implementation of an SDN technology in the transport network and SDN controller in all our OBs. But the first question is, why SDN? I guess many of you know, but I will share with you the reason why Telefónica is working in SDN. First of all, for simplifying the network and OSS integration, we will be able to decouple the network and the OSS, and we will be able to change the technology in the network and the OSS independently. I think this will foster the innovation in both layers, and we will be more flexible of changing whatever component if we have a requirement for doing so. A key reason is automation. I think transport network are more and more complex, and we have to automate. It is a must. Many of the tasks that we are doing today in the transport. The best way of automating within is SDN. Another reason is open transport. You saw before that we want to use disaggregation, and SDN is a key tool for disaggregation. And disaggregation will foster innovation because we will have independent hardware and software, and also will open free demand in our commercial selection processes. This is key. And the last reason I have is future innovation. I think for network slicing, for instance, for 5G, will be key. So we have to control each of the layers and then connecting them to a general orchestrator for having a slicing end-to-end that will be provided to the customer. So an end-to-end slice for a given service or for a given customer will be a need, and the way of implementing this slicing in transport for sure is SDN. So this was the why. How are we doing this in Telefónica? Well, I will describe now what is our reference model, the usage of standard that we are doing, the phasing that we are doing in the use case by use case way, and what is our network abstraction model. Our reference model is this one. So we will have SDN domain controller for IP, microwave, and optical. If possible, we'll minimize the number of controllers. So if we can integrate, for instance, microwave and IP in the same box, we will do so. But formally, they are different domain controllers. We will have only one controller per domain. So this means that will be multi-vendor controller. We will standardize the southbound interface, the interface toward the network nodes, and we will standardize for sure the northbound interface. Each of the SDN domain controller will be connecting what we call SDTN, that is the end-to-end multi-layer SDN controller. And this SDTN controller will show a standardized interface toward the higher level, toward the OSS or the service orchestrator. What is our abstraction model? Well, as I said, we have to have standard NBI. This is the key. This is the key for decoupling the network from and SDN from the OSS and the orchestration. I think this is our first focus. We are focusing in NBI, and we are working already on that. The difficulty we have in the past is that we have proprietary interfaces in the NBI, and each of the development of the OSS is difficult. With the standard northbound interface, the development of application on top of the SDN will be easy. How are we doing this? So we have what we call use case oriented. So we are not implementing the SDN controller completely with all the parameters, but we are doing use case by use case. In each of the operation of Telefónica, we define what are the use cases that are bringing more value to the operation, and we define this use case. Once the use case is selected and defined among all our operation, we have a team designing the use cases, so how the use case has to be implemented. We produce the specific documentation for each of the use cases and share this documentation with the vendor. The vendor implements it. We test this implementation, and implement in the network in production. So the difference of this use case oriented is that we are doing progressively and smoothly, and we are not doing this in a completely big bang approach, but smoothly, as I said. A key factor for us is to do this based on a standard. It is clear that SDN interfaces are standardized, but the data model are not standardized. We have to work for this to be standardized, and we have a lot of collaboration with other operators for doing so. We are participating in all the SDOs and also in all the associations for cooperating for the progress of the standard. In the MBI, we are using TAPI from the ONF in optical network and the IETF service model in IP. For SBI, we are using OpenConfig in IP and ONF 532 for microwave. So the level of each of the standards is different, but we are pushing all of them and we are implementing them in our network. This work based in a standard is as well fostered and full with open collaboration with other operator. We are working with other operator, selecting the use cases again in a use case by use case approach. So we define among all the operators where are the use cases. We define and design all the use cases in a collaborative model, and then we push all the vendors from all the operators to implement these use cases. We are doing this in the framework of telecom infra project. Of course, all this work is open. We are sending all the information, and we are receiving collaboration from all the operators. The collaboration that we are working is an open transport initiative, we call internally, and it is included in a new working group in the TIP, in the Telecom Infra project, that we have named MUST. Recently, we have published a white paper, and in this white paper, we have the reference architecture for the SDN implementation, the use case methodology, the methodology I have just explained you about use cases. We are explaining in this in this white paper. We have identified the standard that we are using, and even we explain the taxonomy we are using for the use case approach. So, as I said, this is the first step in this collaboration with the operators that I think will foster the implementation of a standard in the SDN. The working group is called MUST. MUST is the acronym for Mandatory Use Case Requirement for SDN Transport. So the intention is clear. We want all our transport vendors to implement compulsory the use case that we are defining, and we are working with Telefónica, Vodafone, Orange, MTN, Deutsche Telekom, Telia, and Syntel. Okay, so we are going to define the device northbound interface, the domain controller northbound interface, and the hierarchical controller northbound interface. So we are going to define the data model of all the interfaces we have we have explained before. I have explained to you before. The work will be done in the use cases approach, and we will disseminate all the work that we produce in this working group. Okay, and the idea of this is fostering all the innovation and also the standardization of all these interfaces. So this is what I wanted to share with you regarding our SDN project in Telefónica, but I'm sure that you will have many questions, so I'll let time for you to make any questions you would like. Thank you very much.